Hello students, in today's lecture we are going to solve some questions NCERT Exemplar problems 1.37 to 1.41 of the chapter Units and Measurements. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So our question is, the volume of a liquid flowing out per second of a pipe of length L and radius R is written by a student as V is equal to a pi by 8 into P R raised to the power 4 divided by eta L, where P is the pressure difference between the two ends of the pipe and eta is coefficient of viscosity of the liquid, having dimensional formula M L inverse T inverse. Check whether the question is dimensionally correct. It means here you have to find out the given formula of the volume of liquid is dimensionally correct or not. Think about it. So, solution, thinking process. If dimensions of LHS V of an equation is equal to dimension of RHS, then equation is said to be dimensionally correct. Answer: the volume of liquid flowing out per second of a pipe is given by this one, V is equal to pi PR raised to the power 4 divided by 8 eta L. So this is the volume that is given in this question. So dimension of V, it means dimension of volume is equal to dimension of volume divided by dimension of time. Here dimension of V means volume of liquid flowing out per second. So the dimension of volume is L cube and dimension of time is T. So the dimension of volume of a liquid flowing out per second is L cube T inverse. So V is the volume of the liquid flowing out per second. Dimension of P is equal to M L inverse T raised to the power minus 2. Dimension of eta M L inverse T raised to the power minus 1. Dimension of L means length is L. Dimension of R is L. Now we will check the LHS and RHS is equal or not. So dimension of LHS, left hand side is volume. So the dimension of volume is L cube divided by T is equal to L inverse L cube T inverse with square bracket. Dimension of RHS, right hand side, is here pi by 8 is constant value. So dimension of P into dimension of R with raised to the power 4. So this is the dimension of P M L inverse T raised to the power minus 2 into L raised to the power 4 divided by dimension of eta m L inverse T inverse into dimension of length L. So solving these dimensions, you will be get L cube T inverse. So as dimension of LHS is equal to dimension of RHS. Look at here. This is the dimension of LHS and this is the dimension of RHS. Both are equal. So we can say LHS is equal to RHS. Therefore, equation is dimensionally correct. Clear? A physical quantity X is related to 4 measurable quantities A, B, C and D as follows. So the relation is X is equal to A square B cube C raised to the power 5 by 2 and D raised to the power minus 2. So this is the X. The percentage error in the measurement of A, B, C and D are 1%, 2%, 3% and 4% respectively. What is the percentage error in X? Here we have to find out the percentage error in quantity X. Given that if the value of X calculated on basis of the above relation is 2.763, to what value should you round off the result? Think about it. So, solution, thinking process. We will apply the formula for percentage error in quantity X as delta X y X. It is the relative error multiplied with 100. It will be become percentage error. So the percentage error is delta X by X into 100. Answer: given physical quantity is X is equal to A square B cube C raised to the power 5 by 2 D raised to the power minus 2. So this is given. Maximum percentage error in X is delta X divided by X into 100. So this is the representation of the percentage error. If we want to calculate the percentage error of any physical quantity, so first of all, absolute error divided by original value multiplied with 100. So it represents the percentage error. So the percentage error of the X is this one, LHS side. And if we talk about the RHS side, this one, so plus minus A raised A square, so power become multiplied with delta A divided by A into 100, this one, plus B cube, so power comes outside, this one 3 and remaining term is B. So B in term of percentage error, it will be delta B divided by B into 100. Similarly, C raised to the power 5 by 2. So power comes outside with this one and remaining term is C. So C in terms of percentage error is delta C divided by C into 100 plus D raised to the power minus 2. So power comes outside 2 delta D divided by D. This is the into 100. This is the percentage error of D. Now substitute the value. Plus minus 2 into, if we talk about the A, so the percentage error is 1%. If we talk about the B, the percentage error is 2%. And if we talk about the C, the percentage error is 3%. And if we talk about the D, the percentage error is 4%. So after calculation, it will be become this one. So 2 into 1, 2, 3 into 2, 6, 5 by 2 into 3, it will be 15 by 2 plus 2 into 4, 8. So after addition, it will be plus minus 23.5%. So percentage error in quantity X is equal to plus minus 23.5. So mean absolute error in X is equal to plus minus 0.235 is equal to plus minus 0.24, rounding off up to 2 significant digits. So it will become plus minus 0.24. The calculated value of X should be rounded off up to 2 significant digits. The number of decimal places to keep is determined by the first non-zero digit in the error. So 0.235. Here first non-zero digit is 2, which is in the first decimal place. Therefore, the measured value should be rounded to the same decimal place where the first non-zero digit of the error appears. So X is equal to 2.763. It will be 2.8. Clear? In the expression P is equal to E L square m raised to the power minus 5 G raised to the power minus 2. E, M, L and G denote energy, mass, angular momentum, gravitational constant respectively. Show that P is a dimensionless quantity. So here you have to prove that P is a dimensionless, or show that. Think about it. So solution, thinking process. A dimensionless quantity will have dimensional formula as M0, L0, T0. This one. Suppose we have a quantity which is a dimensionless. In that case, the dimensional formula is M0, L0, T0. Solution. So given expression is this one. P is equal to E L square m raised to the power minus 5 G raised to the power minus 2. So here dimension formula of E is ml square T raised to the power minus 2. Dimension formula of M is M. The dimension formula of mass is M with square bracket. Dimension formula of L, here L is angular momentum. So it will be ml square T inverse. And dimension formula of gravitational constant is m inverse L cube T raised to the power minus 2. Where E is energy, M is mass, L is angular momentum, or G is gravitational constant. So this is the given expressions in this question. So substituting dimensions of each term in the given expression, you will get this one. Dimension formula of P is equal to dimensional formula of each term E, L, M, G. This one. This is the dimension formula of E, dimension formula of L, dimension formula of M, dimension formula of G. So here base, if the base is same, power will be added. So M raised to the power 1, here M raised to the power 1, M raised to the power 2, because after squaring it become M square, and it will be M raised to the power minus 5, M raised to the power here plus 2. So it will become this one, M raised to the power 1 plus 2 minus 5 plus 2. Similarly for L and T. If we talk about the L, so L square, L raised to the power 4, and here L is 0, and here L raised to the power 3, and it will be minus 6. So 2 plus 4 minus 6. Similarly for t. So after adding the powers, you will be get m0, l0, t0. Therefore t is a dimensionless quantity because the exponent term of ml and t is 0. So this is dimensionless quantity. Clear? If velocity of light c, Planck constant h and gravitational constant g are taken as fundamental quantities, then express mass, length and time in terms of dimensions of these quantities. So here you have to express mass, length and time in terms of dimensions of velocity of light, Planck constant, gravitational constant. Think about it. So here we have to calculate the dimensions of given quantities: velocity of light, Planck constant, gravitational constant. Solution: thinking process. In this problem, we have to apply principle of homogeneity of dimensions. That is, LHS and RHS of an equation will have same dimensions. So the principle is here, principle of homogeneity. Answer: we know that dimensions of H, Planck constant, ml square t inverse. Dimension of C, speed of light, m0 l t inverse. So this is the dimension of C. And if we talk about the dimension of gravitational constant g, it will be m inverse l cube t raised to the power minus 2. So we know that these dimensions. Let m is directly proportional to c raised to the power x, h raised to the power y and g raised to the power z. So it will be after for removing the proportionality constant, there will be a constant term, so that is k. So m is equal to k, c raised to the power x, h raised to the power y and g raised to the power z. And let this is equation first, where k is a dimensionless constant of proportionality. Here k is a dimensionless quantity, or we can say dimensionless constant of proportionality. Next is substituting dimensions of each term in equation first, we get a new relation. So m1 l0 t0. So just substitute the values, you will be get LHS side is this one and RHS side is this one. So this is the RHS side. So L t inverse whole power x into m l square t inverse whole power y and m inverse l cube t raised to the power minus 2 whole power z. So here z multiplied with inner terms and similarly x and y. So it will be m whole power y minus z, l power is x plus 2y plus 3z. Similarly t raised to the power minus x minus y minus 2z. Now next we will compare of LHS and RHS side. So comparing powers of same terms on both sides. Same terms means m, the power of m compare with power of m with RHS side. So after comparison, here m is 1, m raised to the power 1, and here m raised to the power minus uh, m raised to the power y minus z. So here 1 is equal to y minus z. So this one y minus z is equal to 1. Let this is equation second. Next, if we talk about the second, L x plus 2y plus 3z is equal to 0, because in LHS side the L raised to the power 0. So when we compare the power, so x plus 2y 3z equal to 0. Next term is t. So when we compare the power of t with LHS side, it will be minus x minus y minus 2z equal to 0. And let this is equation 4. Now here we have a 3 equations or 3 variable x, y and z. So adding equation second, third and fourth, we get a new relation. So it will be 2y is equal to 1. So after calculation, 2y equal to 1. So y equal to 1/2. Here y equal to 1/2. Other terms, substituting y in equation second, we get z is equal to minus 1/2. From equation 4, x is equal to minus y minus 2z. So substituting the values of y and z, we get x is equal to minus 1/2 minus 2 into minus 1/2. So solving this, you will be get 1/2. So here x is equal to 1/2 and z is equal to minus 1/2. So putting values of x, y and z in equation first, we get m is equal to k into c raised to the power 1/2, h raised to the power 1/2, g raised to the power minus 1/2. So it will be m is equal to under root m is equal to k under root ch by g. Second is, let L is directly proportional to c raised to the power x, h raised to the power y and g raised to the power z. So you will be get removing the proportionality sign. So there is a constant k, L is equal to k, c raised to the power x, h raised to the power y and g raised to the power z. And let this is equation 5, where k is a dimensionless constant. K is dimensionless constant. So substituting the dimensions of each term in equation 5th, we get a new relation. So it will be LHS side is M0, L0, L1, T0. RHS side is this one. So here we will use the principle of homogeneity. So when we compare the LHS and RHS, we get the value of x, y, z. So here in RHS side, the dimension formula is L T inverse x, and similarly m L square T inverse whole power y, m inverse L cube T raised to the power minus 2 z. Now here power is x, here y and here z, multiplied with the power of ml and t. So you will be get m raised to the power y minus z. Similarly, L raised to the power x plus 2y plus 3z, and t raised to the power minus x minus y minus 2z. Next, we will compare the power of ml t with power of ml t with RHS side, LHS side with LHS side. Here LHS side is M0, L0, L1 and T0, and RHS side is become this one. So when we compare the powers, on comparing power of same terms, we get here y minus z is equal to 0. So let this is equation 6. Similarly, x plus 2y plus 3z is equal to 1. And let this is equation 7. If we talk about the t, so here minus x minus y minus 2z is equal to 0. So let this is equation 8. So there is also 3 equation, first, 6, 7 and 8, and 3 variables x, y and z. So solving these 3 variables, you will be get the value of x, y and z. So adding equation 6, 7 and 8, we get y equal to 2y equal to 1. So y become 1/2. Similarly for x and z. Substituting the value of y in equation 6th, we get z is equal to 1/2. From equation 8, x is equal to minus y minus 2z. So we know the value of y, that is 1/2, value of z 1/2. So substitute the value of y and z in this equation. So it will be, after substituting, x is equal to the value of y minus 1/2 minus value of z 1/2. So it will be minus 1/2 minus 2 into 1/2. So here 2 cancel out. Remaining term is minus 1/2 minus 1. So minus 1/2 and minus 1 is minus 3/2. So here the value of x is minus 3/2. Value of y is 1/2 and value of z is 1/2. So from the principle of homogeneity, we get the x, y, z. So putting the values of x, y and z in equation 5th, we get this one. L is equal to k c raised to the power minus 3/2, h raised to the power 1/2, g raised to the power 1/2. So here 1/2, suppose we have h 1/2, it means it is equal to root h. So here similarly g 1/2, it means root g. Clear? So it will be L is equal to k under root hg divided by c cube. C cube means, suppose c raised to the power minus 3/2. So here 1/c 3/2. 1/c by 3/2. So here there is a 2 term, c raised to the power 1 and c raised to the power 1/2. C raised to the power 3 and c 1/2. C cube, suppose we have a c cube and whole power 1/2. It means c raised to the power 3/2. So we can say c raised to the power minus 3/2 is equal to 1/c cube. This one. So we can write 1 upon c cube in this term. So it is equal to this, like this. Clear? So third is, let t is directly proportional to c raised to the power x, h raised to the power y and g raised to the power z. So removing the proportionality sign, here t equal to k x c raised to the power x, h raised to the power y and g raised to the power z, and let this is equation 9, where k is a dimensionless constant. The dimension formula of k is m0, l0 or t0. So this is dimensionless quantity. Substituting dimensions of each term in equation 9, we get a new relation. So here after substitution, you will be get LHS side and RHS side. Here LHS side is t and RHS side is this one. K is a dimensionless, and C, the dimension formula of C is this one. Dimension formula of H is this one with power y, and dimension formula of G is this one. Clear? So solving this, we get L T inverse X or ml square T inverse whole power y, m inverse L cube T raised to the power minus 2 whole power z. So after multiplication, it will be m raised to the power y minus z, L raised to the power x plus 2y plus 3z, and T raised to the power minus x minus y minus 2z. Next, we compare the power of m or L T with RHS side. Power of m0 L0 T1. So we will get the value of x, y and z. So solving this and comparing powers of same terms, we get y minus z is equal to 0. Let this equation 10. X plus 2y plus 3z equal to 0. Let this equation 11. And minus x minus y minus 2z equal to 1. Let this equation 12. So there is a 3 equation. Addition equation 10th, 11th and 12th, we get 2y is equal to 1. So y equal to 1 by 2. So substituting the value of y in equation, we get in equation 10th, we get z is equal to y is equal to 1 by 2. From equation 12th, x is equal to minus y minus 2z minus 1. So here substituting the values of y and z, we get x is equal to minus 1 by 2 minus 2 into 1 by 2 minus 1. So solving this term, you will be get minus 5 by 2. So y and y equal to z, that is 1 by 2, and x is minus 5 by 2. Clear? So putting values of x, y and z in equation 9, we get t is equal to k into c raised to the power minus 5 by 2, h raised to the power 1 by 2 and g raised to the power 1 by 2. So it will be t is equal to k under root h g c raised to the power 5. Here g raised to the power 1 by 2 means under root g. And if we talk about the c raised to the power 5, 1, so it will be 1 by 2. So here 1 by c raised to the power 5 into 1 by 2. So it means 5 by 2. 1 upon c 5 by 2. So is equal to c minus 5 by 2. So for simplicity, we convert c raised to the power minus 5 by 2 is equal to in terms of this. Clear? Next question. An artificial satellite is revolving around a planet of mass m. The mass of the planet is m and radius r in a circular orbit of radius r. Here the important thing is this: r is the radius of planet, capital R is the radius of planet, and small r is the radius of orbit. Clear? From Kepler's third law about the period of a satellite around a common central body, square of the period of revolution t is proportional to the cube of radius of orbit r, showing using the dimensional analysis, and that is t equal to k divided by r into under root r cube divided by g. So this is the equation where k is dimensionless constant. Dimensionless constant means the dimension formula is m0, l0 or t0. and g is acceleration due to gravity. Clear? So analyze the here we have to dimensional analysis of this equation. We have to calculate the dimensional analysis. Think about it. So solution, thinking process. In this problem, we have to apply Kepler's third law. So here question arises, what is Kepler's third law? So Kepler's third law is T square is directly proportional to A cube. This is the mathematical expression of the Kepler's third law. It means square of time period, T is the time period, square of time period of a satellite revolving around a planet is proportional to cube of radius of the orbit A. So here A is radius of the orbit according to Kepler's third law. Now solution is, we will use the Kepler's third law. So why Kepler's third law? T square is directly proportional to R cube, because in this question R is the radius of circular orbit, but according to Kepler's third law, A is radius of orbit. So just we substitute A with R. So T square is directly proportional to R cube. Now what will be the value of T? So T is directly proportional to R raised to the power 3 by 2. So we know that T is a function of R and G according to question. R is radius of planet and small r, capital R is the radius of planet and small r radius of orbit. So here R radius of planet is, it is a function of radius of planet and acceleration due to gravity. So let T is directly proportional to R raised to the power 3 by 2, R raised to the power A and G raised to the power B. So removing the proportionality sign, there is a constant, and constant, after removing the constant, T is equal to K R raised to the power 3 by 2 R A G B, and let this is equation first, where K is a dimensionless constant of proportionality. K is a dimensionless quantity. So substituting the dimensions of each term in equation first, we get this one. LHS side is M0 L0 T1 and RHS side is this one, K L raised to the power 3 by 2 L raised to the power A and L T raised to the power minus 2 whole power B. Now again multiplied with B, with, so it will be K L raised to the power A plus B plus 3 by 2 here, because the base is same, power will be added, and T raised to the power minus 2B. Next we compare the powers of LHS and RHS terms. So on comparing the powers of same terms, M, the power of M compare with power of M with RHS side, we get A plus B plus 3 by 2, A plus B plus 3 by 2 is equal to 0, and let this is equation second, and minus 2B is equal to 1. Here look at here, minus 2B is equal to 1, because in LHS side T raised to the power 1 and RHS side T raised to the power minus 2B. Suppose here T raised to the power 1 is equal to T raised to the power minus 2B. So after comparison, 2B is equal to minus 2B is equal to 1. So from this, b is equal to what? Minus 1 by 2. So let this is equation third. So from equation third, we get b is equal to minus 1 by 2. Clear? Now next we will substitute the value of b in equation second and we will get the value of a. Yes or no? Clear? So from equation second, we get a minus 1 by 2 plus 3 by 2 equal to 0. So here a equal to minus 1. Here we add the value of a. So minus 1 by 2 plus 3 by 2 minus this one. A minus 1 by 2 plus 3 by 2 equal to 0. So a become minus 1. Substituting the values of a and b in equation first, we get a new terms. So that is t equal to after substitution the value of a. So a is equal to minus 1. So here r inverse. So t equal to k into r cube r whole power 3 by 2 r inverse g raised to the power 1 by 2. So for the simplicity, we can write this equation in this term. T equal to k by r under root r cube divided by g. Here the term, this one, k into r cube, r 3 by 2, r 3 by 2, and r inverse become 1 by r and g 1 by 2. So here it will be, suppose this 1 upon g raised to the power 1 by 2. So 1 by 2 means power. So it will be k by r comes outside. The remaining term is r 3 by 2. So we can write r 3 by 2 r 3 whole power 1 by 2. So it will be r 3 by 2. So we can write of this term r 3 by 2 is first r cube whole power 1 by 2 and divided by 1 by g 1 by 2, g raised to the power 1 by 2. So we can say k by r into r cube means under root r cube divided by g. So it will be under root g. So both r and g having root, so it will be k by r into under root r cube divided by g. So this equation comes like this. Clear? So this is the mathematical expression. The important thing here is, when we applying formula, we should be careful about r, small r. Small r is the radius of orbit and capital R is the radius of planet. Clear? So the mathematical expression is this one. Here the important thing is this, the more about the Kepler's third law. Kepler's third law we will learn in upcoming lectures. So Kepler's third law gives using the Kepler's third law we will solve the satellites period of satellites problems, like problems. Clear? Kepler's third law. Thank you for your attention.